All right, we are going to go ahead and start with breadth first search. So I have an array list of previously visited nodes and a queue to use for the search. We add the parent, and as soon as we're in the while loop, we're going to remove that node, update the space if it needs to be updated, update the time since we popped up a node. Then we are going to check if it's the goal. If not, then we're going to generate the children. For each child that has not been previously visited, add that to the children under the parent. And then for each child in the current parent's children, we're going to add it to the queue and mark it as previously visited. And yep, that's how that one works. Then we'll go ahead into my depth first search. Unfortunately, I was not able to get depth first search to work. So this is my recursive attempt here. So what I had intended was it adds the parent to previously visited, checks if it's the goal. If not, it's going to generate the children. Same as breadth first search, then it's going to check if it's been visited. If not, it's going to add for the children. And then for each children, it was supposed to recurse on each child with the previously visited list that is supposed to be getting updated. Unfortunately, that did not work. I also had an iterative approach here that I left just commented out so you can see. My attempt here was similar to breadth first search, except for with a stack here you can see. So I pushed that onto the stack, marked it as previously visited, popped it off the stack, checked if it's the goal. If it's not, then I want to make the children, and for each child that hasn't been visited, mark it as visited, add it to the current state's children array, and then for each child, push the next one onto the stack. That one was not working for me either. It was kind of running in an infinite loop. So then I have my uniform cost search here. So I went with a priority queue here. This little snippet of code here just adjusts how the priority queue is going to be ordered, which is according to my path cost method that I have up towards the top. So then I add the parent to the queue and basically follow exactly what I did for my breadth first search, except for with a priority queue now. So we update the space that needs to be updated. We're going to update the time, check if it's the goal. If not, generate the children. For each children that has not been visited, we will add it under the current state's child array. And then for each child, we are going to mark the child's parent as the current state that we're in. We have the cost as the cost that it took to get to that state, and then we will update the total cost here and then add that child to the queue. For my greedy best first search here, we have a similar thing as well. So I have a priority queue. I have an out of place function up towards the top that determines the H1 heuristic, which is how many boards are out of place, and it orders them according to this function. And then basically the same code as I had before. So I have a priority queue and then a previously visited list. I am going to update the space, update the time, check if it's the goal state. If not, generate the children. For each child that's not being visited, add it to the current state's children array. And then basically do the same thing again that I did up top, just update the parent, the cost, and the total cost, and then add it to the queue. My A-star search with the heuristic from above is similar, except for I have this F1 function here that I now use to order the priority queue. And then I follow exactly the methods that I did above. I'm not going to repeat it if that's okay. And then I did the same thing with A-star search for H2, except for I have an F2 function right here that does that with the second heuristic, which is the Manhattan. I will go look up for that now so you can see it. The rest of my code is exactly the same. And then I just update this queue size to make sure that that's the same. I tried a little different idea there. So for the heuristics, if we go towards the top here, I will show you what that looks like that I did. So here I have the Manhattan distance that calculates that, and then my F2 function that calculates the full function cost. And yep, we can see this running now. So let's take a little, all right, let's just do easy and browser first search. There we go. And then we'll just do it again. We will do hard, and let's do 3D best first. All right, thank you so much for watching.